Mr. Morgan Hendry, an alum of the Tower Hill class of 2001. Mr. Hendry currently works for the Jet Propulsion Lab, also known as the JPL, in Pasadena, California, and has worked on some impressive projects, including the production of the Mars Rover and the Soil Moisture Active Passive mission. During his years at Tower Hill, he was a part of the Tower Hill pumpkin jumping team. He built a launcher that was made solely of PVC pipe and garage door springs for about $100. He told me the night before the competition, they realized that the device that they had built would destruct with fire. So they spent many hours the night before the competition trying to get it ready. After a few last-minute adjustments, they shot the pumpkin over 100 feet, good enough for second to last place in their age division. Mr. Hendry also did an array of things during college. Before working full-time, he had 3 summer internships at JPL. During the 3rd summer, he worked with a robotics group to develop surface sampling systems to grab chunks of Saturn's moon tightly for further study. Finally, while building the Mars Rover, Morgan played a large role in its construction and its landing on Mars. He helped build over 15 components of the Curiosity rover, and one of the most important things he did for the project was build a large box and support structure that sat on the top level. The box included over 75 plus pyrotechnic charges that were necessary for its successful landing. The Mars Rover was launched in November of 2011 and landed successfully in August of 2012. Please help join me in welcoming Mr. Morgan Hendry.
God, when you listen to my short-form bio, it actually sounds like I know what I'm doing. But if you look at it from a different angle, you could easily call me a failure. You see, I failed to get into my dream college of MIT. I failed to get into my second choice college, Caltech, who, mind you, now pays my salary. I failed to get into Cornell, Princeton. Even Virginia Tech's aerospace engineering department would not let me in their doors. I failed to ever get into the 2-mile club in lower school. I failed to score more than 2 points per basketball season, despite being 6'4". It took me 3 tries to get a 710 on the math section of my SATs, bombed my GREs, and I got a D+ in my ordinary differential equation class in college. I failed miserably to escape the Tower Hill dress code. I get cold shakes when I leave the house without a belt on. I had failed at a ton of stuff. And yet, despite the failures, I still have something sitting on the surface of another planet that I built with my own 2 hands. It'll persist for hundreds, maybe thousands of years, unless the Smithsonian decides to go get it. In which case I would have failed at that as well. So some of these things were an unfortunate combination of events. Some of them was just me being careless. But a lot of the failures in my life were due to the belief that desire was enough. So many times I thought that if I wanted it badly, that was all that I needed to get it. That if I deserved it, it was meant for me. It's easy to slip into this mindset where you think you don't have to put in the hard work to get something. Even the most talented people in the world fall into that trap. See, I didn't have that raw talent, and I still thought the desire was enough. See, I was intelligent back in the day, but I wasn't a star student. I had pretty low initiative. Little jubs up, little awkward. I had this terrible curly hair that would not stay flat. I swear, my mother and I, every morning, would take a handful of mousse, 5 hair clips, and try and put a part into this thing. And sure enough, by the time lunch rolled around, there'd just be this giant, ungodly wave and crunching mess. It was disgusting. See, I wasn't terrible. I was just average. And I don't want to give the impression that I had some bad childhood. Far from it. I had 2 parents and a brother who loved me very much, and a family that instilled me with great values. My father was a mechanical engineer. My mother a nurse who went out and started a medical equipment business. So in my life, I was not only just surrounded by mechanical devices, big and small, but also this drive to go out and do something bigger than yourself and to put in more than just the bare minimum. But still, it was tough, and as the external pressures kind of came down on me, I turned inwards. I was fascinated by the quiet ticking of the world around me, a world that, like myself, was largely ignored. I guess in some ways, it's not surprising that I latched on to space. I found my dad's rocketry box growing up when I was in 4th grade, and together we built our first rocket. It was an ST's Lancer, in sleek yellow with this plastic fin can. And I still remember that first launch over in Rockford Park. The tension of the countdown, the shriek as this tiny motor cut through the cold morning air, and the sulfurous aftermath that was remained after the rocket disappeared from view. You see, the only thing we found after that launch was the yellow nose cone. But it didn't matter that we lost the rocket. I was hooked in. I went and I found Mrs. Vale Greenbaum, the 4th grade science teacher, and I asked her if we could start a rocketry club during recess. She said yes. And I'll tell you, it was the first time in my life that I was up in front of my peers and they actually cared about something I was doing. It felt incredible. I dove into the history of NASA and learned about experimental aircraft, and I spent my nights stargazing. As I got through rocketry, I learned that I was more interested in the thing that the rocket was carrying rather than the rocket itself. I wanted to launch bigger and more complex payloads, some of the first digital cameras that were coming on the market, advanced staging systems. Every mission I did had a larger purpose behind it. As I came to my freshman year in high school, I remember clearly sitting on my parents' bed on July 4th, 1997, watching the Pathfinder mission land on Mars. I was watching the broadcast live on CNN from the Jet Propulsion Lab in Pasadena, California. It was the first time America had put something on the Red Planet since the Viking mission in 1976. It was incredibly exciting. And as I dug deeper into the Jet Propulsion Lab, I found that the mission really resonated with me. Everything they did pushed beyond what they had done before. Everything they did was meant to understand our place in the universe. It was that idea of playing on a larger stage that carried me through my bachelor's and master's degrees in astronautics at the University of Southern California between 2001 and 2006. But it wasn't until I took a writing class my junior year in 2004 that I crystallized what I think my personal mission would be in life. See, Writing 340 was a technical communication class with a community service bent. The year I took it was special in that we partnered with an external organization to address humanitarian issues in a small African village called Njili in the Democratic Republic of Congo. The organization came in and started talking to us about the environment in Njili, the abject poverty there, the lack of clean drinking water, the lack of access to electricity, the poor roads, the crime that these people had to deal with every day. And the project that they asked us to dig deep and solve for them was to build a computer lab. To which I said, what? A computer lab? Are you freaking kidding me? How can you use a computer if you have no electricity? How can you use a computer if you're sick at home with a viral infection? You guys are nuts. You got to fix the other stuff first. When my team didn't get put on the Africa project, we protested. In fact, we demanded that we be allowed to look at the water purification and power generation issues that we had identified. The teacher relented. We put on our engineering caps and we started breaking the problem down into requirements and constraints. And after one day of research, just one, I identified something called slow sand filtration. See, slow sand filtration was a technology that had persisted since the Roman era. It was reliable. It used gravity to pull water through it and purify it. No power was needed. It used local rocks, sands, and soils. It was inexpensive. It was perfect. When it came time to pitch this idea, I sold the concept in 3 slides. The power team followed suit. We nailed this thing. The question was it implemented? Sadly, no. There are too many politics outside of my control. But I learned 2 important things from that experience. One, that the skills I was developing as an engineer had the ability to affect the lives of men, women, and children all over the world. And 2, it left me with this unfulfilled goal to leave the planet in better shape than when I found it. And I swore the next time I had the chance to go after that goal, I wasn't going to let it slip through my fingers. In 2007, I began my 8-year career at JPL. My first job was working on the Curiosity Rover, as Ryan had said, and I delivered several components for the rover chassis. When we hit a launch slip in 2008, I transitioned on to the Soil Moisture Active-Passive mission. It's an earth science mission designed to look at how much water is trapped in the top 5 centimeters of the ground. I've got a short video that will tell you a little more about the mission. Good place. You know, how many rocket scientists does it take? So as you can see, SMAP had the ability to do a lot of incredible things for the planet. It had the ability to understand when droughts and flooding would happen, to better predict areas susceptible to wildfires, to let farmers know how much they'd have to water their crops. It was definitely a mission that could help me leave the world in better shape than when I found it. I was excited to start. My desire to meet my life goal was so great, I would have mopped the floors for this project if they let me. Unfortunately, in the aerospace industry, there is a job more grueling and less glamorous than janitor. The project made me something called mass properties engineer. And the idea of the mass properties engineer was basically to make sure that SMAP spun straight. So SMAP is a spacecraft that's broken down into 2 big chunks. The bottom half stays stationary in space and points at the sun to generate power. And the upper half spins at about 14.5 times a minute with this giant deployable reflector on the top. Now the reason we need that big reflector is to see tiny details and intricacies of the soil moisture on the ground. But as you know, if you have a telescope, you can only see a small window of the ground. What we have to do is spin this around to get a bigger field of view. That enables us to map soil moisture around the world every 3 days. Now, you take one look at SMAP and you realize we have no business spinning this thing. I mean, you look at it, it's weird. One science magazine writer told us it looked like something that came out of a Dr. Seuss book. And it does. Look, I mean, spinning spacecraft are not uncommon in the aerospace industry, but typically they make them cylindrical and compact, easy to balance. To our knowledge, SMAP would be the first time we ever tried to spin a big reflector like this. And if we failed, the mission architecture gave us no way to correct it on orbit. We would learn, if we did our job right, the first time that we spun up. And if we failed, well, nothing we can do about it. Mass properties were a mission-critical problem for SMAP, and the solution lay at the end of a 6-year grungy journey. I learned how difficult it would be about 6 months in, when we were completely imbalanceable, totally broken. The dynamics team, the group associated with understanding how the vehicle would fly in orbit, called an emergency meeting, and it was one of those rare times that working at NASA looks like you would think it would. It was a group of ragtag engineers crammed in a tiny conference room with decrepit office equipment, trying to understand a mission-critical problem that would break a spacecraft. Ideas were sparse, and being close to the problem, I decided to throw something into the ring. See, my job to that point had been moving parts around on the spacecraft, trying to balance this 2D seesaw. And anytime something changed, the system would swing wildly to another state. I'd readjust, and it would happen again and again. We were way too sensitive. I'd attempted to move every single component on this vehicle to try and make the problem better, except for our giant spinning radar dish. We had assumed that the scientists had picked this sacred position and that we couldn't touch it. But I hypothesized that if you found the optimum position for that reflector, it might make not only the scientists happy, but the system less sensitive. I made the pitch. I told the dynamics team of the software I'd have to develop, the analyses I'd have to run. And at the end of it, the lead looked at me with this quizzical glare and he said, "Do you really think you can do all that stuff you just said?" So throughout my life, I've gotten used to tackling bigger and bigger challenges, of breaking problems down into small chunks to solve them. It's how I learned the basics of satellite design in a month my freshman year of college and locked down a coveted JPL internship. It's how I redesigned my Tower Hill pumpkin chunker hours before we had to fire it for the first time. It's how I navigated a 10-day tour of Belgium, Germany, and Poland with my band who wears safety only 2 weeks after a major JPL design review. You see, it's not about having the balls to take on a problem that doesn't have a solution in the back of the book. It's about controlling your fear of failure. It's about releasing it slowly as you formulate the solution to a problem, and then letting it go when the rubber hits the road. So when the dynamicist asked if I could do it, I said, "Yeah, I think I can." And the next few months were exhilarating. The project was looking to me to come up with a solution. I called on every single thing that I learned in my engineering education. And you know what? At the end of the day, I was right. There was an optimum position to put this reflector that made the system less sensitive. The work of the dynamics team won us a group achievement award for the project. And the first time I presented these results to the team that was building our reflector, they almost gave me a standing ovation. That doesn't happen in business meetings. I was flying really high at this point in time. I thought I was untouchable. But that would change. So I mentioned that my job was to understand the balance point of this vehicle. And to do that, you need to know a little something about all the parts on it. There's tens of thousands of nuts, bolts, struts that go to make up a mission like this. And each of them has about 30 parameters causing us to wobble on orbit and blurring our view of the ground, distorting our science. It would take me 3 months of 12 to 14-hour days to comb through the system line by line and try and understand the changes that were happening. The minute I finished, the system would be so different that I'd have to start again from scratch, line by line. Imagine a sadistic 5-year game of whack-a-mole, where the minute you take out one problem, another one rears its ugly head. And if you miss a mole, hundreds of people get to see. 14-hour days became more common on average. There were 16 hours I would be sitting in my office trying to figure this stuff out. The 60 to 70-hour weeks I was putting in were coming under increased scrutiny by the project, as were the 5 to 7 hours I managed to scrape by just to keep my music career alive. One manager said to my face in a meeting with SMAP's second in command, he didn't believe a thing that I calculated. Another took a comment sheet during a design review, crumpled it up, and threw it in my face. My peers, when they heard what I was going through, told me to run. They told me to get off the project as fast as I could because I was destroying my career. Some of them even told me to leave JPL and start over somewhere else. Every single day I questioned if leaving the world in better shape than when I found it was worth it. There was a period of time where it took every ounce of my strength to pull myself out of bed in the morning and slump to work by 8:30. 9:30, I'm sorry, everyone else was there at 8:30. And then there were the worst days where I would get into my car in an empty JPL parking lot, close the door, and just scream at the top of my lungs. It was the only thing that I could do to get the rage and the frustration out of my system enough to safely drive home. To understand how I got through this, we have to go back to 1999, my junior year here at Tower Hill. You guys know it's a year of really great uncertainty in your lives. You're trying to figure out who you are. You're trying to figure out how to convince that one college that they should let you in. And if you're like me, you're trying on a lot of different hats. I tried on engineering through rocketry and Pumpkin Chunk, and I tried on law through mock trial. I took Latin for 6 years thinking I might want to go to medical school, maybe. I even tried on the tiger head briefly. I learned that mascotting is not my true calling. But after doing all this stuff, I was just average. I was still just another face in the crowd. You know, one of those hats that I tried on was drumming. I first put it on in the 4th grade, and, you know, I did it because I had to. If things are like I left them, you still have to choose if you want to do band or chorus back in the 4th grade. And there was no way I was singing. These pipes are reserved for one. So I took lessons from my grandfather, who was an ex-Navy jazz band drummer, and I took lessons from Tom Palmer in the jazz department at the University of Delaware, and I slowly got better. I worked from the 6th grade jazz band to the 10th grade jazz band with one of my best friends, Todd Mishiro, as my co-drummer. And you know, in 10th grade, we settled into slowly degrading Mr. Perkins' hearing, which was a wonderful calling. But you know, it was always something I planned to give up. It was just something I did because I had to. So one walk from the music building back to our lockers, we were approached by a group of seniors. And the seniors looked at Todd, and they looked at me, and they said, "See that guy right there? That guy really knows how to play." And they laughed and they walked away. And Todd, being the great friend that he was, told me, don't listen to them. They don't know what they're talking about. You're a fine drummer. But it was like a bomb had gone off inside of me. See, I'd been pushed down in gym, and I'd been at the edge of throwing punches, but held back. I'd been made fun of for my weight and just wanted to curl up and die. But that was it. I was sick and tired of being average. I knew the best musicians in the state went to Allstate. And so I set my eyes on the Allstate jazz chair, and I started practicing. Every day I would lock myself in my attic and I would slave my playing to a drum machine, not tolerating any deviation. I would tear apart the Tower Hill concert recordings and listen for weaknesses in my playing. And after 3 months of practicing and a terrible audition where I had my drumsticks backwards half the time, I found out that I had made it. The greatest rewards in your life are going to come from the hardest work. And you see, desire isn't enough. At some point, you have to roll up your sleeves and get down to business. Those 3 days of All-State Jazz Band opened up a world of music to me. The conductor, Shelley Berg, offered me a spot at the University of Southern California. He got me into a high school rock band called Half Slide, gave me the confidence to go out and form a Rare Safety with 4 incredible gentlemen 10 years ago. We're still recording music. We're still playing. We're still lining up tours. It's the thing that gave me the experience of hearing a fan in Poland with no grasp of the English language scream John Bonham at me. You guys get the let out. You know what I'm talking about. You see, throughout your life, you're going to have to choose whether you want to spend your time or invest it. I'm not going to put myself on some pedestal and say I'm as talented as the guys in my class who went off and formed the Spinto Band, or really any professional musician. I'm semi-pro at best. But I got to say, all those life experiences I've had in music, it seems like it was worth 3 months of hard work back in 1999. So let's go back to 2012. Let's go back to SMAP. I'm sitting there and I'm thinking, is it worth changing the world? Is it worth my immediate happiness to be on this project? Is it worth sacrificing all I'd worked for 11 years to get to that point? As I was lying in bed awake one night, I told my fiance that even if this cost me my career at JPL, I was going to finish. Because when you're given the opportunity to go after a life goal, you do not say no. In life, it only really matters if you deliver on what you promise. And in my case, I had 4 months to prepare for 4 major tests on SMAP. We had 4 large assemblies. Each of them we were going to measure for its balance point, like putting it on the edge of a knife and finding where you could level it out. If those tests matched my math, nobody could question if I was doing my job right. I buckled down, I designed the hardware I needed, I sharpened my pencil, I looked at the analysis again. I began to repair 4 years of damaged relationships. Because even if these managers didn't agree with me, they still deserved my respect. And they were still some of the greatest engineers on the planet. I can only hope to do what some of them did in their careers. Somewhere in those 4 months, I also managed to get married to an incredible woman who stuck by me through MSL and SMAP. I can talk about successes in my life, but I would be nowhere if she hadn't been by my side. The debugging and the checking went until the night before the test, late on a Friday. The last minute, I discovered one final error, some bolts that were in the wrong spot that would have thrown off my analysis. And for some weird reason, I knew in that moment I'd found everything. Don't ask me how. Maybe it was instinct. Maybe I was just sleep deprived. You guys know nothing about that. So I walk in the next day, and I realized that I had predicted the weight of a 150 kilogram object to 0.3 kilograms. That's 300 paper clips. I had located the balance point to within half of a millimeter. I could have balanced this thing on a scalpel if I wanted to. The remaining measurements that I did would follow suit, and the system would become less and less complicated as the chunks got bigger. More importantly, the people who had been criticizing my work for all these years began commenting on the quality of my character, my ability to get the job done. There was one final measurement for SMAP last November up at Vandenberg Air Force Base in Lompoc, where we launched our rocket this January. And after we were cleaning up, I realized that this was going to be the last time I ever saw this spacecraft with my own 2 eyes. the last time I ever saw it here on Earth. I'm not ashamed to say I got a little choked up at it. I mean, SMAC has made my life a living hell for 6 years. But I knew every inch of her. And I know that sounds weird to say. I was saying goodbye to an old friend. And so I said good luck. And I walked out of the clean room. So what comes next? I don't actually know. You see, we've launched SMAP. It's successfully deployed its boom and its reflector. We've powered on the instruments, and they've learned that the Sahara is dry and the Amazon is wet. We've got a little more tweaking to do. But we haven't spun it up yet. You see, you've caught me at this interesting moment in my life. On March 23rd, we spin up SMAP for the first time. On March 23rd, I'm judged on 1/5 of my life. I stand before you today in a state of unknowing, much like some of yourselves. Unlike you, I have no control over my fate in this matter. And that's okay. I'm not terrified, not afraid. I've done everything I can to make this thing a success. My father once told me an engineer stands by his work, and I do. I've succeeded in many things in my life, and I hope to succeed on SMAP because of all those failures that I've had, not in spite of them. You see, we at JPL are imperfect people, attempting deeds that require perfection. And the way that we do this is by failing every single day, in every conceivable way, until the day that it counts. If we don't fail on our own accord, we push our systems to failure. Because you do not know your own limits until you push yourself to the brink. And when we get to that day, the important day where it has to work, we've done our job right, we've run out of ways to fail. Every failure is a chance to learn and grow. Every failure is a reminder that you cannot rest on your laurels or the name of your institution. Every failure is proof that there is no shortcut to success. You see, that is how you change the world. And that's how you change your world. It's not some flash of insight or desire or passion. It's this fire that burns in you for months, years, your entire lives. Some days it's this roaring inferno that you can't contain. And some days it's just this fragile little ember you're trying to keep alive. And on some days, the important days, it's a candle you pass on to the next people in line. I can't tell you when or where your spark's going to come. All I can ask is, how hard are you willing to fight to keep that fire alive? How hard are you willing to fight for yourself? Thanks, guys.